collaboration with the Cyprus Mail, this is the Cyprus News Digest with Rosie Charalambous.
This week we're going to explore the mysteries of space and find out about the benefits of the European space programme. We'll hear about business opportunities.
We could, from space, give a lot of new services and provide a lot of new opportunities to the society at large.
The varied uses of the Copernicus programme.
The vessel's owners know which route to take to reduce their fuel consumption.
Ask if the cost is worth it.
It's a program which costs the EU taxpayer about 4.3 billion euros over 7 years.
The earthly problems that can be addressed from space.
The challenges are climate change, food security, supply of water, clean water in particular, and we need to build satellites that can measure this. And this is something that has a 10, 20 years horizon that we really help measuring these parameters, which have an impact on the global population, on migration, on security itself, safety of people.
And meet the Director General of the European Space Agency, who believes that it can unify people on Earth.
If you are in space and astronauts are doing pictures of the Earth, you do not see any border.
I spent 2 days earlier this week at Tallinn in Estonia for European Space Week. Now, a lot of people I've spoken to have said, why is Europe spending so much money going into space? Perhaps the connection hasn't been made by how space exploration and research impacts our everyday lives. We live in a connected world, and it wouldn't be connected if it weren't for the satellites that are up in space keeping us all in touch with each other. That's just one example, but there are many, many more. Now, one of the people we met while I was in Tallinn was Philippe Brunet, who is Director for Space Policy, Copernicus and Defence at the European Commission. And I asked him which direction he thought space policy in Europe was going to take.
I think that we are witnessing really a new start, in particular in a space segment which is quite new and called the new space, in particular in the USA, which is space considered as an economic tool, whereby we could, from space, give a lot of new services and provide a lot of new opportunities to the society at large.
Do you think that the general public actually understands that role for space exploration and satellites and so on? Because I think a lot of people have just sort of thought, oh, you know, we put men on the moon, we send people up in rockets. And a lot of, for years, I think, public opinion was sort of saying, why are we doing this? And suddenly we're putting it to serious good use for people on Earth.
The science will always exist in the future, for sure. But a part of space has been used for commercial purposes already, even if people did not realize that the SATCOM, when they were witnesses the opening of the Olympic Games, for instance, that was through satellite of telecommunication. So this means that satellites providing service is not in itself something new. What is new is the magnitude and the absolute new approach vis-à-vis space, where in all the different sectors of the society we realize that space, and in particular space-borne data, could give benefits.
But what about the future policy? Because we keep pushing back boundaries, but we don't actually have a clue, do we, that in 20 years' time somebody may come up with an idea and land something on Jupiter or whatever that would give whole new possibilities. So it's really sort of grasping the unexpected and the unknown, isn't it?
Okay, I will take two examples, and one based on your science fiction approach. The first example is that, for instance, we have an absolutely tremendous challenge for the humanity at large, which is the climate change. If we want to monitor the greenhouse gas emissions, to curb those emissions, to assess all the different events which will be the consequences of this climate change. We do need space. It's a bit like doing meteorology, but not for 2 or 3 days, but to know what will be the consequences in 15 years or more. Going to your example, science could be the first step to a space which will become afterwards a kind of community for humanity. Let's assume we go to one of the moons of Jupiter. That will be science, because we will need to get there. We will need to be accustomed for the environment there. And if we found there something, maybe we will be in a position to extract new minerals. And then from science, you will go to development, and you will go to industrial use of space. And the new space, it's this second part. To have, for instance, far from having just one international space station, just for scientific purposes, but to have a lot of industrially produced space stations which will be used as relay or launch pads from Earth to go several times to the moon back and forth. So the conception is not to have a border, waterproof wall between research and development and industrial application, but to have something which is logically used with different objectives, not a one-shot mission, but something which is more sustainable and which can pave the way for new technologies in space.
Okay, one other thing that has come up, I think, during the discussions here has been this idea of space junk, and we have lots of satellites up there looking after and trying to improve the way we look after the environment and sustainability on Earth, and maybe in the meantime creating a bit of a pollution problem in space. What about that? How does the EU approach that problem?
First, for the satellites which are launched by the EU, they are all equipped with mechanisms in order to provide for deorbiting at the end of their life, in order not to create additional junk. The second point is that we have launched some research projects in order to develop, through different technological means, the possibility to reduce the number of debris. Basically, we have, for instance, a call in the current space research program to have a kind of Hoover for certain orbits in order to get rid of the debris. There are other possibilities, for instance, to impact the debris from lasers based on Earth in order to modify their own orbits and to remove them. So the problem is there. The more we will launch satellites, the more we will potentially create debris. But I think that there is now more and more people which are very sensitive to this fact. And unless there is international convention, that will be up to the wisdom of the different satellite operator to equip their satellites with that.
But it is something that's being looked at least by the EU.
Yes.
We've been talking to Philippe Brunet, Director for Space Policy, Copernicus and Defence at the European Commission. Andreas Veispak is Head of Unit for Space Data for Societal Challenges and Growth at the European Commission. He joins us to tell us a little bit more about the Copernicus programme. So what actually is it?
So the Copernicus programme is Europe's Earth Observation Programme. It's an integrated programme consisting of satellites and services which monitor the Earth primarily for environmental protection and also for emergency and security reasons. So to simplify, it's a programme which includes satellites, which brings the data down from the satellites, combines it with data from the ground, and then transforms that data into services which are of public use, and also makes all the data available on a free, full and open basis to everyone in the world.
The problem is getting people who aren't very techy, perhaps, to make use of the data, and I think that's where the Copernicus Accelerator and all these new businesses come in, because they're in a sense the middleman, or they will be, won't they, so that Mr. Joe Public and businesses can access the bits of data that mean they can pass it on to people.
Yes, I think that's correct. I think that the final users of Copernicus data, be those farmers or public authorities or energy companies or shipping companies, really, the palette is vast there. They aren't experts in space data. So what you need between the data which comes down from the satellites and the final users are what I call the translators. The Copernicus services, which are dealing with land monitoring, sea and marine monitoring, atmosphere monitoring, climate change, security and emergency monitoring, form that role, and they play that part already. But what we're seeing here today in terms of research institutes or downstream businesses, it is really for them to transform that data and information into something which is easily usable and accessible to end users. That, I would say, is one of our main challenges. In fact.
And in smaller chunks, of course, because that's
Yes.
how it's easier to use.
Very much so. It's obviously all the data that comes down is not always used, and given that the system is generating something to the tune of 10 petabytes of data a year, it would be quite difficult to deal with it all as a whole.
I think people can understand a lot of why this is done, but you always come across someone who says, but we spend billions on that, is it worth it?
It's a perfectly reasonable question to ask. It's a program which costs the EU taxpayer about 4.3 billion euros over 7 years, which translates to about €1 per EU citizen per year, which is actually less than a price of a cup of coffee. On the other hand, when we look at the benefits which society as a whole derives from this program, then those outnumber the cost by a factor of, I would say, 1 to 10 at least. And when you're looking at things on which it's quite difficult to put a price, such as the protection of the environment, such as climate change, such as human life, I think that factor increases, significantly more.
How can you quantify that figure, those benefits?
Quite simply. So obviously it's a cost-benefit analysis in essence. So the cost is quite straightforward. It's always the same with public programs. It's quite easy to estimate the cost. It's more difficult to estimate the benefits. And then you look at all the use areas in which Copernicus is used. We can never do that to the full extent, but we take the main value chain. So that could be environmental protection, that can be agriculture, that can be the energy industry, that can be insurance, that can be urban planning. And we really play through the scenario and try to quantify the costs in each of these value chains, which we then bring together. We tweak them for any anomaly, so to say, and then we're able to derive the overall figure from that. So it's quite a standard cost-benefit analysis in the end.
And that's Andreas Veispak, Head of Unit for Space Data for Societal Challenges and Growth at the European Commission. Thibaud Delourme is team leader for Copernicus user Uptake at the European Commission. I asked him to explain the Accelerator program.
The Copernicus Accelerator is our program for startups. So we coach the startups that use Copernicus data. Copernicus is the European Union Earth Observation Program. So it's a tool that the Union has to monitor our planet. So to make sure that we have the right capabilities to observe our environment, to protect our environment and to protect our citizens. In practice, what we have is a range of satellites which are orbiting around the Earth and that take pictures of the Earth on a very regular basis so that we can follow the evolution of the environment on a very long run and very regularly. So these satellites are a property of the European Union, of all citizens, and they deliver data for free to all citizens.
So citizens or indeed businesses can go
Absolutely.
online and find the data, and governments, I suppose, as well,
Exactly.
to see how they should be forming their policies.
Absolutely. So really the idea is to have a tool to monitor our environment so that we can make decisions based on these information that we gather. So indeed, as you rightly said, our first customers, if I want to say so, are the governments and municipalities, which are most of the time in charge of protecting our environment. But we also work a lot with the businesses. Here you are at the Copernicus Accelerator at the moment. We have 100 startups which are developing products based on our data, and which then in the very short-term future they will sell to their clients to various applications. Maybe I can develop a bit on that, I don't know.
Yes, give us an example of the sort of applications
Sure.
that have come through, because the accelerator's
Yeah.
been going for a while. I mean, this isn't the first time.
Yeah.
So what would you pick out as some of the more successful applications that these young people have come up with that are now in use and, in effect, impacting European citizens?
So we have an extremely wide range of applications. Just to name a few, for instance, we have applications related to air quality to help our municipalities monitor the quality of the air in their streets and to help citizens decide whether it's the good day or not to go running or not, whether they should avoid running today because there is too much pollution. So this is something that is working at the moment. We also have applications related to the monitoring of our oceans to make sure, for instance, that we know how the currents are evolving, and knowing how the ocean currents are evolving is extremely important for ship owners, because then they can optimize the roads that they take to reduce their fuel consumption. So this is another application that we have, is to help the vessels owners know which route to take to reduce their fuel consumption.
And I think it also can show you who is doing illegal fishing, for example, in the oceans.
Absolutely.
What about farming? Agriculture is a huge part of the European Union in so many different countries and different environments. How does it impact that?
Absolutely. We have a lot of application in the agricultural field. It's part of what we call precision agriculture, whereby farmers can use satellite data, and in particular data from Copernicus, to help them run their farm in a more profitable and at the same time more environmentally friendly way. And for instance, through satellite data, they're able to know how their plants are doing and whether, for instance, they need more water, more irrigation in specific areas of their fields. So it avoids having to use too much water in the entire field. You can actually just put the water where it's the most needed, because thanks to satellites you can actually monitor the state of the plants and actually know whether they need more water or not.
And this data is available, as we said earlier, to absolutely everybody.
Absolutely.
Where can they find it? I mean, a lot of people listening to this are going to say, wow, I want to have a look at that. So everybody can.
Absolutely. So just go on copernicus.eu. You'll be able to find all information to access the data. The data is entirely free. Everyone can access it and try it very easily.
Thibaud, Delourme, team leader for Copernicus user uptake at the European Commission. Dr. Josef Aschbacher is Director of Earth Observation Programs at the European Space Agency. He joins us to explain the importance of what the agency is doing, particularly with regard to Earth's observation.
The European Space Agency is doing a lot of things in Earth observation. We're having three main lines of activities. One is building the meteorological satellites together with EUMETSAT and for EUMETSAT, which is the geostationary satellites and the polar orbiting satellites for weather forecasting. You see them every day in TV when you see the satellite, the clouds over the screen going across the image. These images, these data come from satellites which we build. The second line is what we call the Earth Explorer line, which are science missions. Science in the sense of really addressing key questions of scientists, of top scientists in Europe, of parameters that have to be measured. Take climate as an example, climate change, which of course is a key factor and is impacting everyone. And these scientists are asking us, tell us how fast is the ice cover melting on the Arctic area, for example, or on glaciers in continental Europe. And we design instruments and satellites that measure these parameters. And there, with these science missions, we call them Earth Explorers, we also deploy cutting-edge technology which has not flown before in space, so really entering new domains in technology terms as well as science terms. And the third line is Copernicus, which is also the main topic of the conference here in Estonia, where we develop for the European Union, but funded jointly by the European Union and the European Space Agency, the so-called Sentinel missions. Sentinels are those satellites that monitor all aspects of the planet, the oceans, the atmosphere, the land surface, the poles, in order to really better understand the Earth system and therefore make better decisions for our citizens in Europe and outside Europe. And Especially in Copernicus, we are actually building up the world's best Earth-observing system. Nobody else, not even America, which normally has, I would say, quite remarkable capacities, not even America or other countries have something similar to Copernicus. So really, Europe is building up and is leading in Earth observation through Copernicus, but also the other domains which I just mentioned, meteorology and the Earth explorers.
And I presume that since it is a service that's sort of offered to everybody, that you share this information with, as you say, America and other countries. But isn't it quite important that cooperation with other countries like India, I'm thinking in particular, is up and coming in this, China, for example, that you need maybe the satellites to all be orbiting in a sort of united way so that you're getting almost a real-time picture of what's happening? Because the European satellites, I mean, they're going around, but you may not get the right picture at the right moment.
No, you're absolutely right. Satellites, by their nature, fly around the world and cover every piece of our planet. So by definition or by physics, satellites are not only staying over Europe, but they are covering the whole globe. And therefore, international cooperation is a must. We do cooperate extremely well with various players in America, with NASA, with NOAA, but also with the Indian Space Agency, with the Japanese Space Agency, with the Chinese partners, with also partners in Africa, for example, or with Australia, where we are working closely together on various domains. Sometimes this cooperation is technology, that we are flying on one satellite instruments built by Europe and by America. For example, in Copernicus, Sentinel-6 is one of these examples. Another example would be with Japan, where Japan is providing a very important instrument on one of our satellites called EarthCare, which we are building together. We built the satellite, but Japan is providing one of the main instruments on board the satellite. So yes, we work on technology terms, but also, of course, in the use of data. One important aspect of Earth observation in Europe, certainly implemented by the European Space Agency, is that our data policy is free and open. That means the data which we are acquiring from these satellites are available to everyone free of charge at any place of the world. And I think this is a very important success criteria and is a very important aspect of global cooperation, because these data are free and therefore everyone can get them, and this builds up a lot of opportunities for cooperation.
And what about the future? Because I presume that there will be other topics coming up, maybe in 20 or 30 years' time, and you may need to think, we need to monitor that as well. So that involves new instruments, new satellites. Where's it going?
Where is it going? Of course, space is evolving extremely fast. What we see at the moment, especially in Earth observation, is a very fast developing commercial market where private entities are developing what we call small sats, satellites of a relatively small size, but many of them, hundreds of them and sometimes several hundreds of them, which are complementing some of the larger, more precise satellites which we are building through government or public funding. So this combination of big and small, big satellites, very accurate, but also many smaller ones which are anchoring on the bigger ones, is a very fundamental trend which we are observing now. And I think this is one of the big challenges which I see, is to combine publicly funded activities with commercially funded activities, and of course to ensure that the commercial sector is thriving and therefore developing its own business and making money at the end of the day from these investments. And this is at the heart of the European Space Agency's policy in order to develop space technology for Europe, but for European industry, so that industry can build up a very competitive capacity on the world market. And this is something that is happening very fast. Venture capital companies are coming in with tens, or if not hundreds of millions of investment in this domain. And we are catching up with this wave, which of course is originating from Silicon Valley, but is also now coming over to Europe. And one of the big challenges which I see personally is how can a public entity like the European Space Agency help a very vibrant commercial scenery developing in Europe. In fact, I've just reorganized my Directorate of Earth Observation Programs and built a new department called Future Systems, where these future aspects and these system aspects are being emphasized and being built up in order to really develop and support European industry and increase European competitiveness. Then when it comes to future challenges, which parameters are being measured and required in the future, of course we know what the challenges are. The challenges are climate change, food security, supply of water, clean water in particular, and we need to build satellites that can measure this. And this is something that has a 10, 20 years horizon that we really help measuring these parameters, which have an impact on the global population, on migration, on security itself, safety of people, and this is something which we support with the instruments, the technology which we develop.
You mentioned food security. Now, that's something that I think concerns quite a lot of people. It was mentioned in one of the meetings we had earlier today that a lot of private companies and markets are accessing the Copernicus data. That surely means that those who want to can buy up futures in food security and create problems rather than help you solve them.
It's absolutely true that private companies are using this data and converting it into information which is used in commodity trading, for example, in the futures market. Yes, that's one of the applications. It's an information which they use for their purpose and their business which they create. But the same technology is also used by farmers in order to better manage their fields, to use less fertilizer, therefore less poisonous substances, and therefore have a more environmentally friendly way of managing their fields. So you see, it's the same information which can be used for various purposes, either future trading or the farmer to manage better his field with less money and use of less chemicals, but still producing a high yield of the crops. So this is something, yes, I'm not saying that the use of satellite data for future trading is bad. I mean, it certainly serves a certain purpose in the global economy. But this is not the question which the European Space Agency is answering. We, as the European Space Agency, provide the data which are being useful for a variety of customers, future traders being one of them, but many others as well who are making very good use of this data.
And that is Dr. Josef Aschbacher from the European Space Agency and the Earth Observation Directorate.
You can subscribe to the Cyprus News Digest on iTunes for free and get the program downloaded to your phone or tablet so you can listen anytime, anywhere.
The Director General of the European Space Agency is Professor Dr. Jan Woerner, and he's a great proponent of space as a unifier. When I met him in Tallinn, I asked him why.
If you are in space and astronauts or also robotic systems are doing pictures of the Earth, you do not see any border. You do not see any border in Europe. There is no border between France and Italy, between France and Germany or whatever. Even UK is always on the same map, also sometimes there are some clouds. So I think this message we get from space, we should use it on Earth. And space is above all earthly borders, above all earthly crises. We can work together in space with East and West, with North and South, and ESA is a good role model for that.
You mentioned the clouds over Britain, so
Yeah.
I guess that's a little cue for me to mention Brexit. EXAT, I think, is based in
Yes.
Oxfordshire.
Yes.
You do a lot of work with non-European agencies, so will Brexit make a difference to cooperation in this field with the UK?
I never heard that UK will leave Europe. I heard that they will leave the European Union, and I'm very sad about that, and even angry, because I think it's a mistake, but this is my personal opinion. We are very happy that the UK remains a partner in ESA. So the European Space Agency, as an intergovernmental body, has already members who are not members of the European Union, like, for instance, Switzerland and Norway. And therefore, it's clear that UK will stay in ESA. This is the good message. The difficult message is, of course, we have to see what does it mean also for our employees in Harwell, in Oxfordshire, and the other way around, British citizens working at other ESA premises. So we have to solve that one, but I'm quite sure that this can be solved. And as I'm always arguing for, we need pragmatic solutions for this Brexit issue. It's a decision. I still think people can change in their opinion, but it was decided. Now we have to find pragmatic solutions, and space can be a bridge for these earthly problems.
Well, and one of the earthly problems is atmospheric pollution. Now, I know Sentinel-5 has just been launched, I think. That fits into the whole Sentinel coverage, if you like, of Earth with Galileo and Copernicus and all the rest of it. So what will it be doing?
So it's a full family. The Sentinel family is a full family. We have with Sentinel-1, we start with radar technology, Sentinel-2, it's optical, and so on and so on. And Sentinel-5, Sentinel-5P, is looking to the different parts in our atmosphere. And there will be another one, which will be Sentinel-7, which will have a special view on CO2 emissions. So to find the locations where the CO2 is emitted. So therefore, Sentinel-5 is giving more information about different gases within the atmosphere, and therefore it helps also for the future not only to monitor, this is one thing, but also to find out where are the sources. What can we do on a political level to decide to reduce all of these emissions?
And let's finish with Horizon 2020, because that's something that's very much a buzzword at Space Week in Estonia, of course. And you were talking about disruption and attracting young people to take part in Horizon 2020. Can you just explain what it entails?
So when I'm talking about Horizon 2020, I do this always in the bigger framework of research. And what we need is we have to give new ideas really a possibility and not say, we tried it, it's not working. I mean, the world is changing. We have totally different technologies today, and we might have totally different technologies tomorrow. And we should give possibilities for people to develop something. And this is then also inspiration and fascination, where we can use space especially for that one. And if we have inspired and fascinated people, then they are motivated also to work within our society. So it's far beyond just an industrial advantage or economic advantage. It's about the society as such. And I think Horizon 2020 and other research activities can pave the way for the future.
But you have been very successful indeed with the European Commission and all your partners in attracting business and sponsorship to further this goal.
So I'm not at all against return of investment. I'm not against. But I always say we also need developments and ideas where you do not see the direct return of investment. I will give you one example. Albert Einstein, some 100 years ago, defined the theory of relativity. And according to the theory of relativity, time is not an independent thing. It depends on velocity and gravity. So without knowing, and for years, for decades, the Einstein's relativity theory was just something for university professors, no value for the normal citizens. But today, the navigation system depends heavily on knowledge of relativity theory. Without knowing the theory of Albert Einstein, our systems would be wrong by 500 meters in just 1 hour. So it would be worthless. So therefore, give also ideas away, a possibility which are far away from our day-to-day life.
And that is Professor Dr. Jan Woerner, the Director General of the European Space Agency. Well, I hope you enjoyed this week's look at the European Space Programme as much as I did in making it. If you'd like to find out more, you can go to www.esa.int and find out a lot more. Well, that about wraps up this edition of the Cyprus News Digest. Many thanks for your company. Hope you'll join me next week. Till we meet again, take care and God bless. Bye-bye now.